Kirchhoff's rules. So there are two rules of Kirchhoff. One is junction rule and other is loop rule. Okay. This point, the roads are meeting one another like this, and this point where all the roads are meeting is called junction. Consider some wires connected as shown. All the wires are meeting at a point, and the point where the wires are meeting is called junction. Okay, so let junction is any point in the circuit where the current can split. Where we can split the current is called junction. So consider a junction. Let I1 be the current coming towards the junction, and I2 be the current coming towards the same junction. I3 is the current going away from the junction. I4 be the current coming towards the junction, and I5 be the current going away from the junction. So you can see that we have 5 wires, and they all these wires are meeting at this point, and the point is called junction. So in the three wires, current is coming towards the junction. Okay, so current I1, I2, and I4, they're coming towards the junction. On the other hand, I3 and I5
are going out of the
going out of the junction. So we can use sign convention here. How? Incoming current can be considered as positive, and outgoing current we can consider as negative. Okay. So Kirchhoff's current law states that total incoming current is equal to total outgoing current. So incoming current is I1, I2, and I4. On the other hand, outgoing current is I3 and I5. So we'll add incoming current together and outgoing current together, and they are equal. Okay, their sum is same. The sum is equal. Alternate statement of Kirchhoff's current law is that algebraic sum of the currents at a junction is 0. Summation over I is 0. Because we are considering incoming current as positive and outgoing current as negative, so we can take I3 and I5 as negative. So I1, 2, and 4, they are positive, and I3 and I5 are negative. So using sign convention, we can write like this. Okay. Current law is based on law of conservation of charge. The total charge is conserved, and we can use this in open or closed circuit anywhere. This law can be used in an open circuit as well as in a closed circuit. So we have a question here. Kirchhoff's law of junction is in accordance with the law of conservation of charge, current, energy, both A and B. Both A and B. Next, Kirchhoff's law of junction is also called the law of conservation of
charge.
its charge. So next is Kirchhoff's voltage law. Kirchhoff's voltage law is also called as loop law. Okay, loop law. So before we begin the topic, let's understand what is an electrical network. It is a combination of various electric circuit elements and source of EMF connected in simple or complicated manner. Kirchhoff's voltage law states that algebraic sum of potential differences of all components and sources of EMF is equal to summation over IR plus summation over E equals to 0. Sum of potential differences. Potential differences is P is equal to IR, and sources of EMF, whatever we connect, battery source, E1, E2, E3 that we connect. Sum of all the potential differences, all the components of all the components, and all the sources of EMF is equal to 0. Summation over E plus summation over IR equals to 0. To understand this law, let's first see the rules and conventions needed for this. So procedure and convention of Kirchhoff's voltage law. So let's consider a closed mesh. Assume the direction of current. First, we assume the direction of current, and then for a resistor, where current enters the resistor, we mark that point as positive, and where current leaves the resistor, we mark that point as negative. From where the current is entering, we mark that side as positive, and from where the current is leaving, we mark that as negative. Okay, for a cell, take negative sign when you transverse from positive to negative terminal. Negative sign when you traverse from positive to negative terminal, and take positive sign when you traverse from negative to positive terminal. Consider an electric network having two EMF sources, E1 and E2, and 5 resistors, R1, R2, R3, R4, R5 as shown. So due to source E1, current starts flowing in left direction. Let this current be I1. This is current I1. ये current I1 कहाँ से generate हो रहा है? E1 से. Okay. अब क्या होगा? And due to source E2, current starts flowing in the left direction. Let this current be I2. So I1 is the current through E1 and I2 is the current through E2. है ना? And both the currents are moving towards each other. So they'll meet at point D. So D is the junction where the two currents are meeting. Yes. So at junction D, both these currents meet and move to right, and hence this current be I1 plus I2. Clear? So both the currents are meeting at point D, and from D to C, we have the value of current as I1 plus I2. Because upper se we are getting I1 and niche se we are getting I2. And both are meeting at this point, current becomes I1 plus I2 there, and it is moving through the middle wire as I1 plus I2. And again, at junction C, again this current I1 plus I2 splits into I1 and I2. ठीक है, तो I1 वाला अपनी साइड चला जाएगा और I2 वाला अपनी साइड चला जाएगा. Clear? Now, consider this resistor R2. We have this R2 resistor. अब जहां से current enter कर रहा है, current I1 enters in it from upward, na? Hence we mark that as positive, and this will be marked as negative. Look at the cursor. Because current is flowing from in this direction. So we'll mark the point as positive, and current leaves it downward, and hence we mark that as negative. Clear? Similarly, for all the resistors, we can mark the plus minus signs. For resistor R4, downward wala is positive and upward wala is negative. Okay. Similarly, we can mark for R3. In R3, left side is positive and right side is negative. Okay. And for R1, again, so current is entering from the right side. Yes, current is entering from the right side. So we'll mark right side as positive and left side as negative. Clear? Similarly, for R5, we can R5 again, current is entering from right. So we'll mark that as positive, and it is leaving from left. So we'll mark that side as negative. Easy. Now you know how to mark the resistors. Plus minus कैसे mark करना पता लग गया, right? Now, in diagram, how many variables do you see? See, we have two values of current, and I1 and I2. So we have how many variables? Two variables, I1 and I2. So we need two loops. Minimum two loops are required for finding the values of I1 and I2. If you want to find the values of I1 and I2, then we need minimum of two loops. If we have three values of current, I1, I2, I3, then three loops are required. If we have four values of current, then four loops are required. Because we need four different equations. You know how to solve linear equations in two variables, three variables, right? If we have linear equation, we want to solve for two variables, and we need two equations in xy, and in xyz we need three equations. It goes in the same way. So consider the first loop ADCBA. ADCBA. ADCBA, the above one, upper loop. Okay. So in this loop, look at the arrow. So we have I1, R2 and I1 plus I2, R3. Now you can see. See, minus I1, R2. Then we have minus in this wire DC. Current is I1 plus I2. and resistance is R3. So current multiplied by resistance gives potential difference. Okay. And here also current is I1 and look at the cursor movement. Current is I1 and resistance is R2. I1, R2 is the potential difference. And here I1 plus I2 into R3 is the potential difference because current is I1 plus I2. In this wire, we have the current I1 plus I2 and resistance is R3. Again, in this wire, when we go to this BC to B to A towards A. So in this resistor, again the same current I1 is flowing, है ना? And resistor is R1. So we'll write I1 R1. Okay, so we are moving from positive away from positive and entering into negative. Take E1 as positive and all these potential differences as negative equal to 0. Okay, now you can change the sign and write like this. So we'll take E1 as positive. Now this current is entering the resistor R2 and current is leaving from negative of R2 and that's why we are writing I1 R2 negative. Now it goes to D at the junction. It meets with I2 and the current becomes I1 plus I2 in the wire DC. Okay, current becomes I1 plus I2. Now this current is again going through this resistor R3. Through resistor R3, the value of current is I1 plus I2. Again, current is leaving from the negative of R3. That's why we are taking the sign minus. Okay, and goes to C. At the junction C, again the current divides. I1 goes to the upper circuit and I2 goes to the lower circuit from where they were, they were part of this circuit only. No? I2 was the part of the lower circuit and I1 was the part of the upper circuit. Now I1 will go to the resistor R1. It will pass through the resistor R1. Again, this I1 is leaving from the negative of R1 and that's why we have taken this as negative. Let's consider second loop. Second loop is D, C, E, F, D. Again, we'll apply KVL to this loop. KVL is Kirchhoff's voltage law. Okay. Now, tell me.
E2 plus
Okay. So minus current is leaving from the negative of R4. So we are taking minus I2 R4 here.
minus I E2 plus minus I2.
And for this, it's I1 plus I2 R3 with a negative sign because current is leaving from the negative of R3. Okay. And I2 R5. Again, it is negative because current is leaving from the negative of R5. So we'll put a negative sign. So we can write like this. By expanding this, we'll get this. This is another relation. Okay, clear? Okay. So we have a circuit here. We have to find I1 and I2. Okay. I1 is the current produced by this EMF source of EMF E1 and I2 is the current produced by this source. E1 is 6 volts. Its internal resistance is 0.5 ohm. E2 is 10 volt. Its internal resistance is 1 ohm. अब I1 I2 current यहाँ से निकला. I1 through this, I2 through this, and they'll meet at this junction. यहाँ पे the current becomes I1 plus I2 and goes in this direction. Goes through this resistor R. It's 12 ohm and it goes to the other side of it and enters here at this junction again. So this is I1 plus I2 here. So it again splits up into I1 and I2 and goes to the respective circuits. I1 goes to this circuit and I2 goes to this circuit after splitting. Okay, this is what is happening here. Now we will apply loop rule here. ठीक है, to solve this. कैसे apply करेंगे loop rule बताओ.
हम E1 plus 6 लिख लेंगे पहले.
So let's consider the outer loop. Let's consider the outer loop first. Let's consider this loop. I am going to consider this loop.
पहले वाले loop.
Hmm?
पहले वाले loop.
This loop, outer one. So let's consider this loop. We can label it also. You can label it like, label this as A, this is B, this is C, D, E, and F. And this as G, and this as H. We can label it like this. Okay. Now consider the loop A, B, C, D, E, F, A. See, when we consider loop now, we write like this. We start from A and we end at A only. It shows that we are considering something which is closed. Okay. So let's start from this. Let's go in this direction. We are moving in this direction. Okay. Okay, let's write. So it's E1 first. So E1
plus 6.
is equal to E1 is equal to. We are moving from the positive terminal of E1. So we are considering E1 as positive. Now let's go to F and then to E, then to R. We are following the current direction of current, right? So you can see the direction that we have considered here and the direction of current is same. Direction of the cursor, direction of the, that the thing that I have drawn here and the direction of current, they all are same. They are pointing in the same direction. Okay. So current is through this is I1 plus I2 and resistor is R is 12. Okay. So we'll write I1 plus I2 into R for this. Okay. Now we go to D and then to C, then to B. Again, see, we find that here the same current is there, I1 is there, but we have this internal resistance now, so we need to consider this also. So I1 R. This is how I write. I prefer to write.
उसमें तो आपने बताया था negative.
वैसे मन करा लिखने का तो यू कैन राइट लाइक दैट ऑल्सो. जो आपको मैंने अभी एक्सप्लेन किया है उसके अकॉर्डिंग क्या है, यू पुट अ नेगेटिव साइन हियर एंड नेगेटिव साइन हियर इक्वल टू 0 करते हो, तो अल्टीमेटली यू विल गेट दिस ओनली. है ना, अगर आप उसको भी फॉलो कर रहे हो तो यू हैव दिस E1 and then minus sign, because why we take even positive, because we are moving from the positive terminal. Okay, then we go to this and direction of current, this is positive, this is negative, and current is moving from entering to the positive of resistor and leaving the negative of resistor. So we'll put a negative sign and then we'll write minus I1 plus I2R. Okay, and again it goes there, है ना, so we'll write minus I1R. So there is no harm in writing like this also. You can कैसे भी करके लिख सकते हो. ठीक है. When I write, I do not consider the plus minus sign. I just follow the arrow direction and the current direction. If they're following, if they both are in the pointing in the same direction, then they're positive. And if current is pointing in this direction, my cursor is pointing in the reverse direction, then I take negative. Suppose करंट इसमें ऐसे फ्लो कर रहा था और मैंने जो है अपना एरो, मेरा मेरा जो कर्सर है, मैं क्लोज लूप को फॉलो कर रही हूँ. आई एम जस्ट फॉलोइंग इट बिना बिना इसको नीचे उठाए. मतलब जैसे होता है ना कि आपने वो जैसे कुछ बनाया होगा, ऐसे उठाए, पेंसिल उठाए बिना ऐसे करना है ना. तो मैं अपनी पेंसिल उठाए बिना इसको फॉलो कर रही हूँ कि मुझे इसको रिवर्स नहीं जाना. आई गो इन दिस डायरेक्शन ओनली. इफ आई फाइंड समथिंग कमिंग टुवर्ड्स मी, आई टेक दैट एज नेगेटिव. दिस इज हाउ आई डू. ठीक है, सेम ही आता है. Okay, let's put the values here first. For E1 is 6, है ना? So we can write first, write this I1 plus I2 because we are forming the equation now. So I1 plus I2 into this is 12. Resistance is 12, so we can write 12 into I1 plus I2 plus I1R. R is 0.5. So 0.5 I1 is equal to E1 is 6. So this is one equation. Okay, you can simplify it. Let's simplify it further because we have I1 twice here. So we can see we have this 12 I1 and 0.5 I1. So we can write this as 12.5 I1 plus 12 I2 is equal to 6. So this is equation 1. Any doubt? Now let's consider another. अब कौन सा लूप कंसिडर करने का मुझे ये करें. Let's start from here and move in this direction and enter from. Let's consider this loop now. Okay. So consider this is we are moving from F G, है ना? G F E D C H. This is the loop we are considering. कैसे लिखेंगे बताओ अब आप बताओ. E2 is equal to
I1 plus
E2 is equal to I2 R2 I2 R2. Then we have I1 plus I2. Do we have any other resistor? No, we have only two resistors in this loop. Okay, now put the values. I2 is, we don't know. R2 is 1 ohm. So we can write I2 plus I2 into 12. I1 plus I2 into 12 is equal to 10. Okay, so this implies we have 12 I1 plus 12 I2 plus I2 is 13 I2 is equal to 10. Let this equation be 2. Now we are going to solve these two equations and we'll find the value of I1 and I2. करो भाई solve कैसे करें? कैसे करें? Sorry? हाँ जी? वहां से ले लो. यहाँ से start कर लो I1 plus I2R and then you'll get this I2R. कोई फर्क थोड़ा पड़ता है बेटा. Solve these two equations. From here, you will get the value of I1 as minus 42 by 18.5. It is minus 2.27 ampere. And the value of I2 as 2.865 ampere. On solving these two equations, you will get the value of I1 and I2 as this. Okay, why are we getting this negative sign? What does this negative sign represent? Are we getting a negative current? Its direction is reversed. The direction that we have assumed for I1 is not correct. Actual direction is opposite of it. Okay. So this is negative because direction is opposite to what is shown in the figure. Internal resistance is given and we can see that there is no other resistance in the circuit. Okay, so we can see from here that this current I1 is flowing in towards this direction, I3 is flowing towards this direction, and I2 is moving in this direction, and they all are meeting at this point A. So A is the junction point where all the currents are meeting. So at this junction, current is entering from all the wires. We can see that current is entering and meeting at this point A. So we can write, we can apply the junction rule here. It's I1 plus I2 plus I3 is equal to 0. Junction rule क्या होता है? Junction rule होता है summation over I equals to 0. So we have three different currents here in these three branches. So we can simply add them and equate it to 0. Okay. This is first equation that we have got. See, because we have to find the value of I1, I2 and I3. We need three variables are here. So we need at least three equations are required to solve this. Fine. So let's consider this loop first. वहां पे ठंड लगती है ना. Let's consider this loop first. Okay. Now what should I write? Tell me. Hmm? We've started from E1. हम कहाँ से निकल रहे हैं? E1 के पॉजिटिव से, है ना? तो we'll take E1 as positive and we are entering in E2. और E2 में कहाँ पे? E2 के पॉजिटिव में we are entering. होता क्या है? E2 से E से हम अगर निकलते हैं, then it is positive. If we are entering into E2, then then it is negative. So we'll take E2 as negative and E1 as positive. It is E1 minus E2. ठीक है? क्लियर? अब करंट कैसे करोगे? Current I1 is flowing in this. So I1 R1 minus I2 R2. Now put the values. Put the values here. E1 is 2 volt and E1 is, sorry, E1 is 2 volt and E2 is 1 volt. I1 we don't know, we have to find out. And this is 4. So 4 I1 minus 3 I2. So we can write this equation as 4 I1 minus 3 I2 is equal to 1. Let this equation be 2. Okay, now let's consider another loop.
E3 minus E2. E3 minus.
जो भी मन करे ले सकते हैं. We can take this loop also.
वो एंड नहीं.
तो भी ले सकते हैं.
पहले
So
दो
E1
छोटे-छोटे ले लिए, उसके बाद बड़ा वाला.
वो भी ठीक है. वो भी ठीक है. So E1 minus E3 is I1 R1 minus I3 R3 R3. Okay, now put the values. E1 is 2 volt, E3 is 4 volt, I1 R1 is 4 I1 minus I3, R3 is 2 I1. Okay, so we can write this as yes. It's 2 I3. So we can see that all are multiples of 2. No? All are multiples of 2. So we're getting 4 I1 minus 2 I3 is equal to 2. Let this equation be 3. Is equal to 4 I1 minus 2 I3. Na? Is equal to E1 minus E3 we have done. It's 2 minus 4. 2 minus 4 is minus 2. Okay. Now we have got 3 equations. We can solve for I1, I2, I3. We can do one more thing. See, but here we have the relation between I1 and I2. What if we get the relation between I1 and I2 here also? Then we can easily solve for 2 variables and then we can find the third variable. Okay, so for this we need to substitute I3. For I3 we can write from this equation, from equation 1, we can write I3 as
I2
minus I1 plus I2. This can be written. This I3 can be written as 4 I1 minus 2, and for I3 we can write minus I1 plus I2 bracket close is equal to minus 2. So this implies we have 4 I1 minus plus 2 I1 plus 2 I2 is equal to minus 2, and 4 I1 plus 2 I1 is
6 I1.
6 I1. 6 I1 plus 3 I2 is
Plus
equal to
minus.
minus 2. Sorry, 2 I2. All are multiples of 2, na? So we can write 3 I1 plus I2 is equal to minus 1. So let this equation be 4. Now we can solve equation 2 and 4 to get the value of I1 and I2.
Substitute कर देंगे.
2 and 4. 4 I1 minus 3 I2 is equal to 1. 3 I1 plus I2 is equal to minus 1. You can solve these two equations. On solving these two equations, you'll get the value of I1 as minus 2 by 13 ampere. Have you got this value? And I2 as minus 7 by 13 ampere. Now we will put these two values here in this equation. Therefore, I3 is equal to
9 by 9.
minus I1 plus I2. It is plus because minus minus plus minus of minus 2 by 13 plus minus 7 by 13. So it is 9 by 13 ampere. So these are the values. Okay, so we have to find the current in each branch. How many branches do we have here? So let's label these branches first. We have, this is A, this is B, this is C, this is D. Let this be E, let this be F. So we have AB branch, BC is the branch, BD, CD, AD, EF. These are the branches that we have. Okay, and we can see one more thing here, that we have this cell here, it's of 10 volts and a resistor connected, in series with the cell, and current will start from here at this, because this is the only source of EMF that we have in the circuit. Okay, it will follow this direction, है ना, current ऐसे follow इस direction को follow करेगा, and then current divides into these two branches, है ना, current divide हो गया इन दोनों branches में. फिर अब जब ऊपर से current आएगा, current फिर दोबारा divide होगा. So in this way we have 4-5 variables of current. First one variable, 2, 3, 4 variables of current. So let's reduce the number of variables first. So if we assume that current I1 is flowing through this branch and current I2 is flowing through this branch. So instead of writing current I here, we can write I1 plus I2 here. We can assume the current to be I1 plus I2 here. Okay. If the current is I1 plus I2 here, है ना, तो we can easily divide this into two, I1 and I2. ठीक है, क्लियर. I भी लिख सकते हैं, I1 plus I2 भी लिख सकते हैं. उससे क्या हमारा एक वेरिएबल कम हो जाता है, उतनी इक्वेशंस कम चाहिए. अब I1 I2 आ गया यहाँ पे. अब यहाँ पे जब this I1 reaches here, again it splits into two. So let I3 current flows through this. हाँ, और यहाँ से कितना जाएगा, I1 minus I. बिकॉज आपका जो I3 है वो इसमें से निकल गया. मतलब अगर सपोज हमारा I1, लेट्स अज्यूम I1 10 एम्पियर्स है, 10 एम्पियर्स में से एक वायर में गया 7 एम्पियर और दूसरी वायर में गया 3 एम्पियर. तो अगर आप एक को 3 लिख रहे हो और दूसरे को 10 - 3 कर रहे हो तो कोई हार्म नहीं है उसमें. बस यही कॉन्सेप्ट हमने अप्लाई किया कि इफ दिस इज I3, सो दिस शुड बी I1 minus I3 ओनली. अब क्या है, यहाँ से पीछे से I2 आ रहा था, यहाँ से इधर से I3 आ रहा था. So they will meet at this point, this junction D, and the current becomes I2 plus I3. Here the current becomes I2 plus I3. Now I2 plus I3 is flowing in this wire. अब I2 plus I3 यहाँ से आ रहा है, I1 minus I3 यहाँ से आ रहा है, and they'll meet at this junction C. Okay, when they'll meet at this junction, you can see I3 and I3 cancel each other because we have plus I3 and minus I3, and we are left with only I1 plus I2. तो यहाँ पे ये I1 plus I2 वापस आपका नीचे चला जाए. ये आ गया करना, करंट को कैसे डिवाइड करना है. ओके, so let's consider different loops now. First we have A, B, C, E, F, A. Consider this loop first. For this loop we have, start from here. Okay, it's 10, है ना, 10 is equal to, because हम ये बाहर वाला लूप कंसिडर कर रहे हैं, A, B, C, E, F and A, outer loop. So 10 is the EMF is equal to. So अब बताओ कैसे करेंगे. What should I write? Through this resistor, current is I1 plus I2. Through this 10 ohm resistor, current I1 plus I2 is flowing. So we can write 10 into I1 plus I2 for this. Okay. Now अब ऊपर चलते हैं, ऊपर इधर आ जाओ A पे. A से will go to B. Okay. अब इसमें कितना current, you can see the direction of this cursor and direction of the arrow, direction of the current, they are in the same direction. So we'll write 10 I1. Okay, now we have reached B. From B we are moving towards C now. It's 5 into I1 minus I3. So on solving this, we get the equation as 2 is equal to 5 I1 plus 2 I2 minus I3. Mark this equation as 1. This is your equation 1. Now consider another loop A, B, D, A. A, B, D, A. You can see it is a closed loop. We have no battery source, no source of EMF here. So we'll write 0. Okay?
पिछले वाले लूप
कोई
10 वोल्ट था
हाँ यहाँ पे था बिकॉज हमने आउटर वाला कंसिडर किया था ना लूप, पर अब हम इनर लूप कंसिडर कर रहे हैं। यहाँ पे कोई भी बैटरी कुछ भी कनेक्टेड नहीं है ना, तो हम 0 लिखेंगे। कोई भी सेल नहीं है, कुछ कोई सोर्स नहीं है ईएमएफ का, तो विल राइट 0. ओके, 0 इज इक्वल टू, लेट्स स्टार्ट फ्रॉम हियर, इट्स 10I1. अब आपने देखना है कि आपके लूप का डायरेक्शन जो आपने चूज किया डायरेक्शन और जो करंट का डायरेक्शन है वो सेम है. इट्स 10I1 एंड देन वी हैव दिस 5I3. See, when we are moving in this direction, A to B, then movement of the cursor and the movement of the current, they both are in the same direction. So we'll take this as positive. B to D is positive. But when we go from D to A, we are going against this. Now it is negative, minus 5I1. Minus 5I2 we will write. Okay, so on simplifying this, because all are multiples of 5, you can see, we can write our I2 as 2I1 plus I3. This is your second equation.
पॉजिटिव प्लस और नेगेटिव साइन कन्वेंशन
ये साइन कन्वेंशन ऐसे कि आपने देखना यहाँ से शुरू करनी है, यहाँ से पेंसिल रखो अपनी, पहले ऐसे जाओ, करंट का डायरेक्शन आपका डायरेक्शन सेम है, आपने पेंसिल उठानी नहीं है। वो पहले खेलते थे ना, पेंसिल नहीं उठानी और ऐसे पेंसिल उठाए बिना ट्रायंगल बनाओ, पेंसिल उठाए बिना ये बनाओ, है ना, बस वैसे खेलना है आपने। ठीक है, आपका करंट का डायरेक्शन और आपके लाइन का डायरेक्शन सेम है। अब आप नीचे आ गए, करंट का डायरेक्शन लाइन का डायरेक्शन सेम है। अब आप जब इधर जा रहे हो तो आपका डायरेक्शन, आपका जो डायरेक्शन है और जो करंट का डायरेक्शन है वो अपोजिट है, तो इसलिए आप नेगेटिव साइन लगाओगे। आ गया या नहीं आया? बी सी डी भी कंसिडर करो, बी सी डी बी ऐसे।
I1 minus I3
अब देखो, अगेन विल पुट 0 हियर बिकॉज यू नो दिस इज, दो देयर इज नो बैटरी हियर, है ना। अब इसके बाद 5I1 minus I3, 5I1 minus I3, and here we have, we are moving against it now, so minus 10 I2 plus I3, and यहाँ पे minus 5I3. Okay, on solving this equation you will get I1 is equal to 2I2 plus 4I3. This is your third equation. Now substituting I2 from 2 in 3, I2 की वैल्यू को 2 to 3 पुट करना, so we'll get I1 is equal to 2. I2 के प्लेस पे we will write 2I1 plus I3 plus 4I3. So you will get I1 as minus 2I3. Okay. So let this equation be 4. Now we will substitute this value of I1 from 4 to 2. Value of I1 from 4 to 2. So we'll get I2 as, it's 2I1. So for I1 we'll write minus 2I3 and plus I3. So this is minus 3I3. Let this be 5. Now from 1, first equation, fourth equation, and fifth equation. Okay. First, fourth, and fifth. Put the value of I1 and I2 in the first equation. You will get the value of I3. Should I clear this? Because it's 2 is equal to 5I1. For I1, we will write minus 2I3. And for I2, we will write minus 3I3 minus I3. So from here, you will get the value of I3. It is minus 2 by 17 ampere. Now you'll put the value of I1 in, sorry, I3 in I1 and I2, and you'll get the value of I1 and I2. Okay, so I1 is 4 by 17 ampere and I2 is 6 by 17 ampere. This is what you'll get. And similarly you have to find the branch current also, no, this branch current. So I1 plus I2 भी find करना है, I1 minus I3 भी find करना है, ठीक है, I2 plus I3 भी find करना है. तो I1 I2 I3 तो आएगा ही आएगा, बट इसके अलावा ये 3 करंट्स और है, ये भी आपको इसमें सॉल्व करके इनकी वैल्यूज को पुट करना है, तो आपके पास हर ब्रांच का करंट आ जाएगा.